All right, you guys, so right now the dot cam isn't working, so as opposed to doing this under the dot cam where it might be a little bit easier to see, I'm going to try and do this on the board. Hopefully if you blow up the video big enough you can see what's going on. So I'm going to talk a little bit about how we can use a hundreds grid. So this is a hundreds grid. What a hundreds grid does is it shows 100 little squares in 10 rows. So 10 rows of 10 squares each, or 10 columns of 10 squares each. Altogether there's 100 little squares there. We're going to try and use this hundreds grid to model the problem. Megan had 50 pairs of shoes, but her puppy ate 16% of her shoe collection. How many shoes did the naughty puppy eat? Okay, so this hundreds grid is going to represent my entire shoe collection. So the whole grid is going to represent my shoe collection, which is 50 pairs of shoes. So the whole grid is 50 pairs of shoes. Okay, so this is representing 50 things. Now, if this represents 50 things and there are 100 squares, notice that that means each little square is worth half a pair. Now that sounds really weird. An easier way to think about that is that every 2 squares, so every 2 squares is going to equal 1 pair of shoes. Okay. Think for a minute about why that is. If I want this whole thing to represent 50 pairs of shoes, then there would be 1, 2, that's sort of viewable, 3, 4, 5, 6, 7, 8, 9, 10. So notice that I'm getting 5 pairs of shoes on every row. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 2 squares is going to represent 1 pair of shoes. Okay? All right. Now let's think about what we want here. We are asked, or we're told, that the puppy ate 16% of the shoes. So 16% of the shoes have been eaten. Now what I would like to do is shade in 16% of this grid. Now remember what percent means. Percent literally means out of 100. That's what percent means. So if I have 16%, this means 16 out of 100. So if I want to show 16%, and I have 100 little squares, I'm going to shade in 16 out of my 100 squares. So I'm going to shade in 16 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I've shaded in 16% of my grid. So the pink part shows 16%. Okay. Now it's often helpful when we're doing these problems to think about kind of what's being shown, remind ourselves of that. So remember our whole grid is showing my total shoe collection, 50 pairs of shoes. The pink, the shaded parts, so the shaded portion is going to show the eaten shoes. So the shoes the puppy ate. And the unshaded is going to show the, we'll call them the safe shoes, the shoes that were not eaten. Can't spell, sorry. Okay. All right. So now the question really wants to know, how many shoes did the puppy eat? We know that the puppy ate 16% of the shoes, but we want to know how many that is. Well, notice our little reference back here tells me that every 2 squares is 1 pair of shoes. So inside my shaded region, there's 1 pair of shoes, 2 pairs of shoes, 3 pairs of shoes, 4 pairs of shoes, 5 pairs of shoes, 6 pairs of shoes, 7 pairs of shoes, 8 pairs of shoes. So the puppy ate 8 pairs of shoes. 8 pairs of shoes were eaten. Bummer. Okay. Now, notice that we also get more information than that from this grid. This grid also tells us how many pairs of shoes were not eaten, okay? So if I think about the fact that, remember, each little, or each set of 2 squares represents, that's going to be a terrible color choice, sorry. So here's one pair of shoes that was not eaten, another pair of shoes that was not eaten, another pair, another pair, another pair, another pair. Now I could go through and box all of these, and depending on the level of my students, I might. Or I might take a shortcut and say, notice that when I have one whole row, I get 1, 2, 3, 4, 5 pairs of shoes. So 5 pairs of shoes, then I'll have 5 more for 10, 15, 20, 25, 30 pairs of shoes, 35 pairs of shoes, 40 pairs of shoes, and then don't forget these 2 little shoes here. So altogether, 5, 10, 15, 20, 25, 30, 35, 40, 41, 42. So 42 pairs of shoes were not eaten. 8 pairs of shoes were eaten, 42 pairs of shoes were not eaten. That makes sense because altogether I knew I had 50 shoes, and 8 plus 42 is 50. Okay? All right, so now I put another problem up here. This one's a little bit more challenging than the puppy shoe problem. We're going to work it with the same methodology. So this says a company bought 16.2 acres of the 30 acres it plans to buy. What percent of the land has the company already bought? So again, we've got a whole grid here. I've included the little questions that I've kind of given you on your assignment to sort of help you. What is the whole in terms of acres? What is each square in terms of acres? What is each long, so each one of these, in terms of acres? And then we're going to shade in the 16.2 acres and look at what percent of the whole that represents. Okay, there's a little typo on here. This should be 16.2. Okay, so let's see if we can answer each of these questions. So our whole, in this case, is going to represent the total number of acres the company wants to buy. So our whole is the total number of acres that the company wants to buy. So in this case, our whole grid is going to equal that 30 acres. Okay. So altogether, this whole is going to equal 30 acres, okay? All right, so now I want us to think, what is each square in terms of acres? Well, let's see if we can figure this out. Our whole is 30 acres. I have 100 little squares inside of there. So if I take that 30 acres, that's my whole, if I take that 30 acres and I divide it by 100 squares, that's going to give me the value of each little square, okay? Man, now that's a little bit confusing, I think. So let's actually do what is each long in terms of acres first, okay? Notice that I have 10 longs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? So I have 10 longs. So again, I can think of each long as representing 1/10 of the whole. So each long is 1/10 of the whole. The whole is 30 acres. So if I do 30 divided by 10, well, that's a nice number. 30 divided by 10 is 3. So each one of these longs is going to be worth 3 acres, okay? And that's pretty handy. And I'm just going to label that down on the bottom to remind us that this is worth 3 acres, this is worth 3 acres, this is worth 3 acres, 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 okay? Notice it all together, that gives me 3, 6, 9, 12, 15, 18, 21, 24, 27, 30 acres, the 30 acres that I needed, okay? Oh, sorry, I just realized that you can't see all that writing. I'm sorry. Okay, so now we've answered that each long is 1/10 of the whole, which is the same thing as, so each long is 30 acres, not 30, 3 acres, excuse me, just like what we labeled down here. Now let's see if we can label what each square is worth. Okay, so let's zoom in on one little long here, and maybe I'll even draw it. It won't be pretty, but you can go with me on this journey. So here's one long. Okay, it's not perfect, but that one long is divided into, we're going to pretend that those are nice squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares. Okay, now I know that altogether, this is worth 3 acres. Okay, so I need to take that 3 acres and I need to divide it into 10 equal pieces. So I need to take 3 and divide it by 10. But hey, when we're dividing by tens, we're getting those nice decimals. So this is going to represent 0.3 or 3/10. So each of these is going to represent 3/10. And if we add all of those up, that's going to give us a total of 3.3 plus 0.3 plus 0.3, etc. Okay, so each one of our squares is worth 3/10 of an acre. Okay, turn it. Sorry, 3/10 of an acre. So each square is worth 3/10 or 0.3. Both of these say 3/10 of an acre. Oh man. Okay. Whew. So now we know the value of each one of these, okay? And I'm just gonna label this first one with 0.3 to remind us that each little square is worth 0.3. Now let's see if we can figure out the value, or see if we can figure out what percent 16.2 is of the 30 acres, okay? So the first thing that I need to do is I need to color in on my little grid 16.2. Not sure if you guys can see that. I think you can see it. Okay, so we need to color in 16.2. Oh man. Okay, now remember, each one of these longs is worth 3. So if I'm trying to get to 16, I can color in a whole long. There's 3. I'm gonna color in another one. 6, so I'm up to 6 acres colored in. 9 acres. 12, 3, 6, 9, 12 acres, 15 acres. Okay, now if I colored in another whole long here, I would be at 18 acres, and that's more than I need. Okay, so we're gonna need to start coloring in squares. So what we have here so far, this little piece right here, represents 15 acres. Now we have to get up to 16.2 acres. So I'm going to start coloring in little individual squares. So here's 15.3. Adding another little square, 0.3 and 0.3 is 0.6. So 15.3, 15.6, 15.9. Okay, so right now I'm colored in at 15.9. If I color in another square, that'll be another 0.3. So I'm at 15.9. If I color in another square, that's going to be another 0.3, but that gets me exactly to 16.2. So I'm going to color in one more square. Okay, so this colored in portion here shows 16.2 acres. Okay, now what was the question that we wanted? The question that we wanted to know is, what percent of the land has the company already bought? Well, here's the nice thing. We went to all the work to build this model. Our model now answers the question. Because remember that percent literally means out of 100. So I'm going to look at this, and I'm going to see how many of my squares out of the 100 total squares are colored in yellow. Well, I have 10, 20, 30, 40, 50, 51, 52, 53, 54. So I have 54 out of 100 squares. 54 out of 100 squares, which translates to 54%. Remember that percent means out of 100. So the company has bought 54% of the land that they need. Okay. Now, I know this video is getting long, so I want to stop it real soon, but one thing you may be saying is, man, that seems like a lot of work to build this model to answer that question. And maybe you're like, hey, I know how to do a shortcut. I know how to do something like 16.2 divided by 30, and then look at the decimal that I get, convert that to a fraction, boom, done. You're not wrong. That's a perfectly valid method. However, we really want to emphasize, or what I'm really trying to emphasize in this class, are these visual models to try and give meaning to what's going on. Because I feel like a lot of students can do that until they can't. And if they forget that algorithmic approach, or that way of just kind of plugging and chugging, then they start to just sort of randomly divide and multiply, and they don't really have an understanding of what's going on. So I'm not saying that you're going to use a model for every problem. So for example, if I have to work a percent problem in my everyday life, which does happen, I don't necessarily build a model. I use kind of those shortcut algorithms. But because I have this understanding of where those algorithms are coming from and what I want my students to understand, I have that idea of number sense, or a deeper understanding of why these things work the way that they do. That tends to lead to a lot better ability to transfer knowledge from one type of problem to another. It helps build a solid foundation as students move on to higher level mathematics. All right, off my soapbox now, and I'm going to turn this